Hello, welcome to Timas TV. We want to use this example to calculate the potential difference across each unit of overlaid line suspension insulator. In this example, you'll be seeing how the voltage is distributed across insulators and some of the factors that affect the efficiency of the string. So in this example, we are asked to look for a potential difference between across each unit of overhead line suspension insulator consisting of 4 similar units. So we are dealing with 4, and we are also given that and each is the voltage between the line conductor, and each is 60 kilovolt. We also have that the ratio of the capacitor of each unit insulator to the capacitor of each intermediate section of the metal is 5:1. We are also asked to find the efficiency of the string. So at this, we want to quote this formula that says that before we do that, let's look at what we are given. The voltage is 60 kilovolt, and the ratio, let's use N, is 5:1, and 4 units is given. So at this point, we want to look at the voltage across each unit, starting with 1, 2, 3 till the end. In this example, we are actually looking at the unit of 4, where this represents the unit that we are looking at. So if we put 1 here, so we are going to be having 1 plus 1 equals to V1 plus V1 divided by M. So at this point, this will give us V2, and this is going to be V1. Also note that this is V1, and we are being asked to divide. Okay, let's say this is going to be V1 plus V1 divided by 5, because the ratio was 5:1. So let's see how we can do this example and carry out some of the analysis of the insulators in the transmission line. So at that point, we have that V1 plus 1, this is going to be V1 plus V1 plus M, and this is V1 plus V1 divided by 5. So this will give us V2, and this is going to be V1 divided by 5 plus V1. If you use your calculator, you're having 1.2 V1. That means that your V2 is voltage at unit 2 is giving us 1.2 and times the voltage at unit 1. So having done that, let's go ahead. What about 1 plus 2 plus 1? 2 plus 1, this is V3, and we are having this will be this V2. So but V2 prime is going to V2 prime is going to be V1 plus V2. V1 plus V2, and this is giving us V1 into 1 plus 1.2. So that is 2.2 V1. So at this point we have that your V3, that is the voltage across the third unit, is giving us 2.2 V1 divided by 5 plus V2. That's this V2 we're given to be 1.2 V1. So at this point we have that your V3 is 1.64 V1. Then finally we have V3 plus 1, which is V4, is going to give us V3 prime divided by 5 plus this. So V3 prime is actually V2 prime plus V3, and this is giving us V1 into 2.2 plus 1 point this. So this is giving us 3.84 V1. So at that point we have that let's clean this. Let's clean this. So at this point we have that your at this point we have that your V4 is giving us 3.84 V1 divided by 5. This is plus 6 point this, that is 3 V1. So this is giving us 2. This is giving us 2.40 this and that. So we've seen the value for V4 with respect to V1. This is 2.405 V1. So now, but the total voltage on the conductor, you can say the total voltage on the conductor is actually equal to V1, 2, 3, and 4, because we are actually having 4 units, and this is given as 60 kilovolt. So 60 is actually V1 1 plus 1.2 plus 1.6 plus 2.408. Please, this was 8. This has to do with the analysis that we just got, that V4 is 2.408 V1, and V3 was 1.64 V1, V2 was 1.2 V1, and this is V1. So having done this, we have that finally that your V1 V1 is equals to 60 divided by 6.248, and this is giving you 9.6 kilovolt. So at this point we have that V2 is going to be 1.2 times 9.6, and this is 11 point this. We have that V3 is 1 point this times, so this will be 15 point this, and also this is giving us as 2.408 times 9.6, and we have 23.1 kilovolt. So having done this, we have seen each of the units occupying with the voltage. So what is the strain efficiency? The strain efficiency is giving us that voltage of the conductor, and this was given to us divided by the number of conductor, which was 4, multiplied with the value of the voltage that is closest to the conductor. This was V1, V4. So we are having that this will be 60 divided by 4 times on this. So the answer is given us this point this. That is efficiency of the system. So please, I want my student to actually solve for when the voltage is 80, when the voltage is 80 and unit is 6, it's having 6 units, 6 units, having 6 units, and the ratio, which is n, is actually 6:1. So please try your hands on this. What will be the voltage across each of the insulator? Voltage across each unit, and also strain efficiency. Please write your question in the comment section and also answer this assignment accordingly. Call this one assignment 3, because if you're following my videos, I've been giving assignment at each question. So if you have watched the video, please try your hands on that assignment. Write the answer in the comment section.